Okay, I think we're good to go. Good afternoon. Hey, there we go. Come on, here we go. Thank you so much for coming along. My name is Matt McSpirit. I'm a technical evangelist for all things in the data center. You may have seen me on Channel 9 this week, interviewing people, trying to look intelligent next to really intelligent people. That was my job for this week. But as I said, I'm a technical evangelist for our data center technologies. And in this session, we are going on a journey. Advanced PowerShell, Extreme Deep Dive Edition. Are you with me? I'm kidding. Don't worry. We're not going there. It would be a very short session. All right, trust me. Get-VM. There we go. So, this session, migrating to Microsoft, VMware to Hyper-V and Microsoft Azure. We've got a load of different technologies to talk about from a Microsoft standpoint, but also we've got some partner solutions that I want to talk to you about as well. And I've got some good friends from a variety of partners going to showcase some of those solutions to you and really give you an idea of just some of the different ways you can migrate workloads from VMware or even alternative places to the Microsoft platform, be it Hyper-V, be it Azure. So we're going to break the session into a couple of parts. I'm going to talk initially about migrating to Hyper-V. Not specifically VMware initially. I'm going to talk about physical conversions as well, in case anybody's still interested in doing that sort of stuff. So we'll spend a minute or two on that. Then we'll look at moving virtual machines to Hyper-V as well. And then we'll start to focus on Azure. I'll bring two of my good friends from NetApp and Vision up to showcase some of their solutions as well. And we'll wrap up the session and let you go on time. So when we think about migrating to Hyper-V, what is the key tool from Microsoft, at least today, to migrate workloads to Hyper-V from physical and from VMware? And that tool is the Microsoft Virtual Machine Converter, MVMC, as I'll refer to it from now. Now, MVMC 3 is the actual release that we've got available. You'll see it listed on the blogs and on the download center. But in reality, when you install it, it appears as 3.1. So if you're confused, well, this is 3.1, it says here. Don't worry. It's the same kind of thing. It says the major version is version 3, but it'll appear in the product as 3.1. And that was due to a couple of issues that were found initially with MVMC 3, feedback, working with customers and partners, a few quick fixes, and we pushed out a new build for that shortly after. It was released in October timeframe last year, so there's been no other major updates for it since then. This actual release was pushed in December time, so the 3.1. That's the one you want to download. If you can't find that one, just let me know. Ping me a mail. I'll help you find it. But all your good search engines, which I'm hoping is Bing, will help you find that. No problem. But what does it do? Well, if we think back to what MVMC version 2 did, MVMC version 2 was all about converting VMware VMs to Microsoft Hyper-V VMs, hence the name Virtual Machine Converter. However, there was a way of converting physical machines around about that time that was built into System Center Virtual Machine Manager. So if you were still converting physical servers to VMs, you could use System Center. If you were just wanting to convert virtual machines, you could use this free tool. However, in a later release of System Center Virtual Machine Manager, the P2V capabilities were taken out. They're now back in case you didn't know, in MVMC 3.1. So even though the product is called Microsoft Virtual Machine Converter, it can convert physical machines to virtual machines as well. So you've got options there. Now, when you're converting, you can convert from not only VMware and physical to Hyper-V, but you can also do virtual into Azure. And we'll talk a bit about that as we go forward as well. But what are the key things to take away what it does? Well, it's quick and easy to deploy. It's a couple of megabytes to download, very straightforward to install and configure. There's practically nothing to do. And it's very easy to use. So you can start to convert virtual machines very quickly. When I say convert them very quickly, I mean the process of you configuring in the UI is quick. The process of converting the VM may take a little bit longer, depending on the size of your VM. But some new things that came in with version 3 were around support for PowerShell, native support for PowerShell. So that means you can start to build automation around MVMC and convert at significant scale if you put in the effort with PowerShell. Obviously, if you're using the UI, which is easy and quick to use, it's still one virtual machine at a time. So PowerShell allows you to start to scale that out a little bit more. It's fully supported by Microsoft. So you can download it, you can use it. We'll support you in your conversions with that. And at the time it was released, and still to this day, currently, it supports the latest guest OSs, VMware hosts, and Hyper-V hosts. So you can convert from the latest platforms if you see fit. It won't support, or at least Microsoft won't support it being used with the technical preview at this point. If you're thinking, well, will it work with the latest TP2 of Windows Server and Hyper-V that we just released at the conference? There'll be no support for that, but the virtual machine, I imagine, would work fine. It's a 2012 R2 VM that it would convert to, and you could bring that onto a technical preview host. So that would work OK. It's just the product itself may not be supported for running on technical preview just yet. So just something to bear in mind. But when we think about the process, how do we convert from physical to virtual? What's key about MVMC, then? How does it work? Well, firstly, we need to understand just what it can convert. So from a physical perspective, it can do servers and clients. Probably don't see as many clients being converted using MVMC. It's probably not the primary use case, but certainly the server operating systems back to 2008, R2, 2012, and R2 are the primary candidates for physical conversion. Yes, you could convert that old Vista box if you wanted to into a Hyper-V VM. I'll leave that up to you. But once you've started that conversion, you can move those across to Hyper-V, either of these editions. So 2008 R2 SP1, or later, 2012 and 2012 R2. And you'll notice in the brackets after each of those operating systems, it just says VHD. Even though some of the later versions of Windows Server and Hyper-V support VHDX. So as it stands, MVMC will convert to a virtual hard disk, a VHD, not a VHDX, for physical conversion. So just something to bear in mind. And when we think about what the process looks like, you've got your Windows-based operating system that you're converting for physical, and you've got your Hyper-V host. And we'll kick off by installing MVMC 3. Start the process. We need to define a couple of places where we're going to store stuff, the files that will be placed once the conversion is completed. In this case, we need somewhere where the virtual machines are going to live. That could be on your SAN, it could be local disk, it could be on a file share, whatever it may be. And we'll need some kind of scratch space as well where we'll handle some of the conversion steps as we're going through the process. We'll connect to the target. So we'll need some credentials. We'll need to install a little agent in there, run a system scan, and figure out what is on that machine. And once we figure that out, we'll kick off the process, select the volumes, configure the virtual machine settings that we want to have when it's completed, and we'll point it at a host and click Go. And it's as simple as that. MVMC will trigger a volume snapshot. So this is an online operation. This isn't something that MVMC will shut down the host and do a capture that way. This is an online capture. So it's important to bear in mind certain workloads that you might be running in that virtual machine. You may want to think about stopping those services temporarily whilst we do the capture. Because if it was, for instance, a SQL Server or an Exchange box or some workload that was transactional in nature and ongoing while the capture was taking place, we're only going to capture that snapshot at a point in time. And the physical OS will continue for a while. So your data may not be consistent in terms of what you've got in the VM versus what you had in the physical when the process finished. So it's important to think about those things when you handle those services. We'll copy it across to the MVMC conversion host. So how fast is it? Well, it depends on your network. It depends on the machine that's doing the conversion. It depends on the machine that is being converted. All of those will play a factor. So there's no way for me to say 5 minutes every time. Tick. It just depends. It just depends on your environment specifically. If it's a huge host with big hard disks, that's going to take longer. So just bear that in mind. We'll validate, we'll fix it up, we'll make sure everything is as it should be, and we'll attach the virtual disk to a VM that MVMC will create. So you'll have your nice virtual machine sat there, no problem. So we'll take a quick look at what that looks like through the UI. It's not an incredibly dynamic demonstration, but here we are in my environment. I've got a machine that I'm going to point at. So I'm going to choose physical machine conversion for my first one. So you can see, if I zoom in, we've got a big selection of options of what I can do. I'm going to choose physical for this first one, and we'll go next. I just need to give it a name or an IP address, just some way of finding the machine. There are recommendations around firewall ports that MVMC will need. That's important, obviously, if you're going to handle that conversion and that communication initially to do the scan. And I need some credentials in order to query that machine. So I'll go next. I'll click Scan. And MVMC, as it says at the top of the box here, temporarily installs an agent on the source machine and pulls back some information about that particular machine. So it's going away. It's thinking about it. It's looking. And you'll see I actually did it in advance, so the information is still the same. But it knows that it's a Windows Server 2012 R2 standard. In this case, it's got a single proc. It thinks it's got two, well, it has got 2 volumes, but you know if you've installed a modern version of Windows Server, it creates that little recovery drive at the start of the vault or the disk, a small volume there, and then the C volume as well. So it's going to treat those as 2 volumes, which means you're going to end up with 2 virtual disks attached to this VM. One with the first little bit in, and the second with the main C drive volume, if you will. So let me come out of there and click Next. Here you'll see I can select them, and I can choose whether I want to convert this particular physical system and the disks into a dynamic VHD, not VHDX, as you can see, VHD, or a fixed. So I've got the choice here. Now, if I'm looking for the best performance, fixed is preferable, but for this example, I'll just leave it as dynamic, which means the virtual disk size should match the used space, or more or less match the used space here. So in this case, the C drive is 9.47 gig. It will create a dynamic VHD to match the volume capacity, but the usage, the actual physical size of the VHD, will only be around about 9.5 gig. So just something to bear in mind if you're planning doing a lot of conversions, how much space you'll need. So we'll go next. I'm going to give this a name, so I'm going to call this VM003. I could choose the same name, that's not a problem. I don't have to match exactly what the physical system specs were here. So even though it had a single proc, I could give it 4 when it's a virtual machine if I wanted to. It's not a big deal. I'm just going to leave it as is. Go next. Pointed at a Hyper-V host, IP, computer name again. Go next. It's going to validate that I've got permission and credentials to actually query and send the VM to this host. And now I'm all about targeting where I want to store the virtual machines. So in this case, it's a file share, and it says at least 9.74 gig of free space is required. That was the dynamic disk size, remember we talked earlier, of the C drive virtual disk and that little recovery volume as well. So it's adding those together, and it's telling me that's what I need. So that's simple enough. The workspace is that scratch space I talked about before, that MVMC temp that we saw on the graphic. So we just need a little bit of extra space to handle the conversion whilst it's taking place. So you'll see here it says at least 9.74 gig is required as well. So just remember, when you're doing conversions, you're going to need a decent amount of space with the MVMC conversion tool, especially when we talk about virtual machine conversions later on, because there's a period of time where you've got the virtual machine disk from a Hyper-V perspective, the VHD or VHDX, let's say it's 10 gig, but you've also got the VMDK that's been copied as well. So you've got a period of time where you're needing double the space for the particular virtual machine you're converting. So again, another thing to bear in mind with the solution. So I'll go next. Network config. Well, currently it's not connected to anything, but I could just choose to connect it to my Hyper-V switch, which I've called Hyper-V switch. Didn't really think that through, but that's the name in my environment. This is just allowing me to map my cards for when I migrate. So for instance, this physical machine is attached to, let's call it management LAN. When it fails over, I want to connect it to management LAN again, but this time in a virtual world. So straightforward stuff. The summary just confirms, and then you click Go. And just like that, it will kick off the process. That machine will be snapshotted. We'll take the data from that snapshot, we'll bring it over, so we'll consume that roughly 9.5 gig of space in our scratch space, and then we'll start creating the virtual disk from there, and we'll end up with a new virtual machine in Hyper-V Manager. So really straightforward. It's very, very easy, and that is a physical to virtual conversion. Nothing more to it. But I imagine that most people have probably got past that stage. They may be more virtualized, maybe 100% virtualized. But there were often questions around, well, I've still got some workloads hanging around. What's Microsoft's P2V tool? And the reality is, well, it was removed from System Center, so use this, okay, at least for the time being. Now, when we think about virtual machine conversion, there's a few more considerations. Still the same tool, still the same version, but this time there's some more considerations. From a vSphere perspective, a VMware source, conversions from some of the vSphere infrastructure technologies, you'll see ESX, ESXi, some of the previous versions, vCenter. You're going to be thinking, well, VMware have released vSphere 6 now. Do you support vSphere 6? It's not officially supported at this point. Is vSphere 6 probably the kind of, let me rephrase that, are the kind of people who are up to date with vSphere and using vSphere 6 likely to be the ones that are converting virtual machines to Hyper-V? Possibly not. They may be the ones that are still pushing forward with VMware and sticking around. that's fine. The customers who are perhaps sticking on older versions, maybe their SNS subscription with VMware has now expired and they're weighing up their direction going forward. They've not stuck with the latest versions of vSphere. They're more likely to be using a migration tool, whether it's Microsoft or otherwise. But that said, would it work with vSphere 6? I imagine it probably would. And it doesn't need vCenter. So we can target vCenter, and we get a list of your VMs across all of your hosts. Or if you just want to convert a few virtual machines from a host directly, which is what I'm doing in my demo shortly, then I can just target the ESXi host itself. So even if I'm running a small dev test environment, a lab, a remote site, I've got flexibility. I don't necessarily have to have vCenter, which is additional management layer for some organizations. Most organizations will have vCenter if they're managing vSphere at scale. But like I say, for smaller environments, dev test, you may just have a standalone host. We cover both. When we think about what it can convert to, same as with P2V. Hyper-V, obviously, is a target. Previous versions, like 2008, R2 SP1 and onwards, VHD only. And then the 2012 and 2012 R2, you'll get a choice. And we'll see this in a demo shortly in the UI. You've got a choice about which disk type you want to use. My preference would be always to go to VHDX. However, today, if you thought, well, I'll do a conversion to VHDX and then think, I wish I'd have sent that VM to Azure instead. It's not as easy because Azure doesn't support VHDX today. So you could reconvert the VMware VM and select VHD and then push it to Azure. That's another option. But yeah, just bear in mind that if you do want to go to Azure, just go direct. So MVMC will handle targeting Azure directly within the UI. Now, there are two stages to this. Firstly, we'll start the VM conversion. It will go across to the scratch space, and it will start converting that VM. And then, once that's done, it will push the virtual disk, the VHD, up into your Azure storage account, which you define as part of the wizard. Now, that's where the process finishes. It doesn't create the VM in Azure for you, so you just end up with the disk sat there waiting. So you need to go in, or somebody needs to go in, create a VM, attach that virtual machine. Just something to bear in mind. That's how it works today with this particular tool for Azure. I'm going to talk about a better way to migrate to Azure a bit later on. So I just wanted to make you aware that it's in the product. So what's supported? What's supported from a guest operating system perspective? Well, the hardware versions of different vSphere platforms. So as you've gone through the ages, you've gone through vCenter 4.1 or vSphere 4.1, 5, 5.5, and so on. There are different hardware versions with most different releases from vSphere. And we support a wide range of those. And from a guest operating system perspective, there's a big list. Some of them have little numbers which will be quite hard to see next to them. And what that's denoting is, if you want to go to Azure, some of those aren't supported. So for instance, an x86 workload, you can't migrate that to Azure. You can take it to Hyper-V, yes, fine, but Azure supports 64-bit. It also doesn't support clients, so something to bear in mind there as well. From a Linux standpoint, it's important to refer to the documentation, because whilst we support conversion of Linux virtual machines on vSphere over to Hyper-V, there may be, depending on your Linux distribution, a couple of extra little bits of configuration to do in the Linux VM before you actually convert. So just something to bear in mind there as well. In terms of, you think, okay, well, there's a good list of Linux operating systems there, but my Linux distribution isn't there. Will it work with any? It depends, but if it's supported in Azure, that's the key list. It has to be supported in Azure IaaS to work here. Okay, so something to bear in mind. Now, when we think about virtual disks on the VMware side, so on the Microsoft side, on Hyper-V, it's relatively straightforward. Do you migrate to a VHD or VHDX? Simple. Yes, you could choose dynamic or fixed as well, but the choices are relatively few, which is a good thing. On the VMware side, however, we could convert from quite a few different types of virtual disk. So there's quite a lot of different options on the VMware platform. Monolithic flat, monolithic sparse, there's extents and all sorts of stuff. So you'll see that MVMC just has pretty good coverage for those. Okay, so most people will just use the standard, a full-size VMDK or a thin VMDK. We can handle those no problem. As you start to get into some of the more weird and wonderful different configurations of virtual disks, then make sure you check the documentation. But it's a key list. I mean, we cover most of them, so you should be fine. When we think about any other additional requirements, some of these should be relatively obvious. You need to have enough capacity, believe it or not, to handle the conversion. Who'd have thought? You need to have permissions. You can't just walk into someone's data center and just start converting their stuff. That's not going to work for you. You need to have appropriate creds. You need to have capacity. Your conversion machines need to at least be powerful enough to handle the conversion. Don't walk in with an old netbook from 3 years ago with MVMC on there and just expect to whiz VMs around the data center in conversion. It's just not going to work very well. You need to have a decent conversion machine. I'm not saying a supercomputer, but it needs to be, the more you put in, the faster it's going to be. The machines you're going to want to convert, there may be instances where you need to tweak the firewall slightly to communicate through, and some of that is in the documentation. We've used the term here, disable firewall. I mean, it's a bit of a sweeping statement and maybe not something that people are comfortable with. So the documentation will refer to some of the ports that you can disable or open, more specifically, to enable that communication. VMware tools need to be installed. You think, okay, you're asking me to install VMware tools so you can convert the VM. Yes, because we do a lot of that conversion and that communication initially with VMware tools. We want to make sure that it's as clean as possible. We do remove them as part of the process, because when they're running on Hyper-V, when the VM has been converted, we don't need the VMware tools. In the same way, they wouldn't need Hyper-V integration components when the VM runs on vSphere. It just wouldn't be necessary. So we remove those to clean it up. But they need to be there so we can control the virtual machine in a more complete way as part of the conversion. When we think about Linux guests, as I mentioned, the VMware tools, again, should be installed, and for most cases, they're going to be. If you want optimal performance on vSphere, if you want optimal control for keyboard and mouse and all that kind of stuff and the key drivers, you're going to have VMware tools installed, so this shouldn't come as a shock. But other things around Linux, we need to make sure that we've got the right credentials, the right ports, so we can communicate to handle that conversion. But there are, like I say, more VM or more guest OS specifics for specific Linux instances in the documentation that's available with the download. So certainly check that out. And the final thing when you're thinking about converting to Azure, as I said before, when you do the conversion, you select Azure, and we'll walk through this in a minute. Select Azure as the target. Next, 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 finish, kind of like the P2V demo we saw. And when you click finish, it's going to convert locally and then push up to the cloud. There's a number of considerations that are going to impact the time it takes, the size of the virtual machine, your connection to Azure. They're going to have an impact. But even when it's there, when it's got to Azure, you think, okay, my VM's now running in Azure, I can walk away, I'm done. No, that's not the case. You still need to go in and create the virtual machine and attach the disk. That was one step that wasn't included. Straightforward to add, maybe automate it through PowerShell, but something to bear in mind. As I said earlier, there is a better way to convert to Azure, and I'll discuss that in more depth shortly. It puts the virtual disk in blob storage. There are a couple of prerequisites, and this is probably the fiddliest part of the whole process, is getting that certificate set up. Get your certificate that you've got locally on the machine, in the relevant store. Make sure it's up in Azure, and you've got the thumbprint and the certificate, the subscription ID. So there's a bit of toing and froing, getting your certificates right. But once you've got it, you just need to input that information into MVMC, and you're away. The conversion is actually very simple. It's just that initial setup with the certificates is a little bit fiddly on occasion. But there's plenty of guidance on that online. So what does the process look like, and how does it differ from the physical conversion? Well, it doesn't differ drastically. It's just now we're operating at a vSphere level, and we're communicating with some of the VMware tools directly. So we've got our vSphere host, either directly ESXi, or we've queried vCenter itself. And we've got, this time, Windows and or Linux VMs. So when it was physical, it was just Windows servers. Now we've got a bit more flexibility. And we've got our Hyper-V host. We install MVMC, and we define that location where the VMs will live eventually. Remember, that could be SAN, it could be SMB share, you name it. iSCSI, Fiber Channel, doesn't matter. Local even. We need some scratch space. So that combined space needs to be able to fit the VMs and the conversion that's taking place at that time. So if you're converting a terabyte VM, you're going to need 2 terabytes of space for at least for the period of conversion. Once the conversion is finished, you don't need 2 terabytes of space. You just need 1. And then we've got Azure involved as well on a sunny day. There we go. Connect to vCenter or ESXi. Select your guest. You notice it's guest, not guests. It's just guest, one at a time. Okay, so with this solution, MVMC, through the GUI, I can just select one machine. Go. I can have multiple instances running, but through the GUI, I can just have one. That's where PowerShell becomes more powerful to enable you to automate some of this process. So we'll checkpoint the VM first. So this is MVMC talking to ESXi directly or vCenter and saying, that VM, it's leaving you, checkpoint, snapshot. Because we want to make sure that we've got a point in time that if the process did blow up and we had some serious issue, that VM is still there. You can still roll back to it. We don't destroy the original. We make sure that you've still got a point in time before we remove the VMware tools that you can go back to that's clean. Then we'll start to uninstall the VMware tools and kick off the process. So the VMDK and the virtual hard disk, copy and conversion. That takes a little bit of time. The copy process takes time. The conversion process takes time. How long is time? It's a very generic and wide, broad, sweeping statement. Again, it just depends. It just depends on the size of the VM, the original host, getting it across the network, the machine that's being used for conversion. Now, I've shown twice here where P2V and V2V, I've installed MVMC on the host that is the target. It doesn't have to be. I can be using an MVMC conversion machine, point it at my ESXi there, send it to the Hyper-V there. So I've got flexibility. I don't have to converge them in that way if I don't want to. We then validate everything. So once it's finished, we make sure everything's as expected, everything should be working. We connect it to the Hyper-V. We copy the virtual disk from the scratch and create the virtual machine. And it's, from that point forward, it doesn't take that long. It's just that initial conversion that takes the time. Now we're at a stage where we're just rapidly spinning up the VM. If, however, you chose to go to Azure as part of the UI, then it would have just sent it to Azure instead. But just copies the virtual disk to Azure to blob storage. So if we have a quick look at the environment again. Which one have I got here? So we'll look at the Azure one first, very straightforward. I've gone through a few steps. Machine type was virtual machine that I selected. Migration destination was Azure. Azure connection is just me specifying my subscription ID and stuff and thumbprint, and they're sensitive, so I skipped on those screens already. But it just lists all the storage accounts that are associated with the subscription that I provided. I go next. I choose the source. So this is me pointing MVMC, whoops, there we go, MVMC at my, in this case, ESXi host directly, straight in. So I'll choose that one. I'll give it creds. In this case, I'm using the root account, probably not a best practice. And my VM01 VM that's been detected there's only one VM on there. But if you pointed it at a vCenter, it would show loads of VMs, depending on how many you've got. An individual ESXi host, it would just show the VMs that are on that host specifically. And you'll see it gives me a bit of information about this particular VM. Not too much. I'll go next. Which machine am I going to convert? In this case, it's already decided for me. What are the creds that I need inside the virtual machine? So I've given vSphere creds earlier. Now I need credentials for the VM itself. And you'll see I've got some options on the final state of the source virtual machine and the final state of destination. And what that's saying is, OK, you're going to convert this VMware VM to, in this case, eventually, Azure. When the process is finished, do you want to keep the VM running on vSphere and just leave the one on your target switched off? Or do you want to do it vice versa? You've got choices. However, when you're converting to an Azure location, you can't choose the final state of the destination virtual machine. Why not? Because it doesn't create one. It just puts the virtual disk up there. So there's no way that could work. If you're doing it from a Hyper-V perspective to Hyper-V host, this option, as we'll see shortly, will be one that I can use. Oops. So let me come out of my Zoom. We'll go next. I've got my scratch space. That's going to hold the conversion stuff while it's being converted, all the data. And just like that, we're at the end of the process and finish. Now, if I go back out and go to Migrate to Hyper-V, the wizard changes it a little bit. But this time, I'm going to say, OK, let's go to Hyper-V 01, my Hyper-V host. I choose, again, disk. Where's it going to live when it's finished? In this case, it's going to live in my VMs folder. Could be SAN, could be DAS, could be SMB. It's going to be dynamic because I want to keep space quite small. I'm going to leave it as VHDX, which is the default. I'm going to go next. The source is the same as we saw before, the same vSphere host. Same VM in this case. Same information, but here I can choose final state of source machine and destination. Now, you probably wouldn't have both of them on. That probably wouldn't be a best practice. I'd say choose one or the other as a best practice, at least. It's fairly common sense. But if you want to, that's fine. If you're isolating the Hyper-V one and not connecting it to your production network, that would be OK. If you're planning to instantly connect them to the network, then probably wouldn't do that. I'm going to leave both off at this case. Scratch as my location where I'm going to handle the conversion, and then finish, and off it goes. And that conversion would start, and that would take a varied amount of time depending on, again, the conversion machine, the network, the size of the virtual machine, and so on. So that's a little walk around MVMC. Now, really simple tool. It's got some advantages, because it's simple, it's free, which is also cost-effective, it works, it's supported, but it's also got some downsides. Single virtual machine conversion at a time. It's a cold conversion, which takes time. There's downtime involved for the workload. As soon as that process kicks off, we're going to snapshot, as we saw, or checkpoint, then the VM's going to be shut down. And for that period of time, until the conversion is finished, that VM is off. So if that was your Exchange server, your SQL server, your line of business app, it's down for that period of time. How can we start to accelerate? Well, we automate. I said before, there's a PowerShell layer natively in MVMC, so you could write some pretty powerful PowerShell and include that within some of your automation tools that you may already have within your environment, Microsoft or otherwise. So some powerful runbooks to automate conversions. However, Microsoft worked with the community, worked with some partners to build out what we called the Migration Automation Toolkit. Now, this was built for a previous version of MVMC, but still works with version 3. And it essentially gives you a PowerShell UI. I call it loosely there. It's an interactive PowerShell experience, menu-driven, that enables me to scale out the conversion of virtual machines using MVMC as the conversion engine. Now, the conversion itself won't be any quicker. It can't magically make MVMC run faster. But what it can do is it can help you to scale out individual MVMC conversions. And what I mean by that is, you've got your first MVMC machine. You've stuck a little SQL database on there. SQL Express is fine, or you can use an existing SQL Server database if you want. And you've installed MVMC. You run a collection command. So from the PowerShell window, you run a collect. And it goes and queries your vSphere infrastructure. Goes and queries it, brings back a list of VMs. Where does it store them? Where better? The Notepad. So it pumps out a Notepad list of all of your VMs. Yep, we're really going high-tech here. Notepad list, which you trim down to reflect the batch that you want to convert at this time. So maybe it's a list of 100. Probably wouldn't recommend 100 in a batch. I would say maybe put it down to 10, maybe slightly more, depending on how many MVMC machines you're going to be using for conversions. So we have this little list, this user-ordered list. And once we save that file, we check it back into the database. So it gets stored in the SQL Express or SQL Server database back on the control machine. And then what we've done and established is we can either convert those, start going through that list. And MVMC, if you've just got one machine running MVMC, it'll just start working through that list. It'll do one. When it's finished, it'll do the next. And you can set a simultaneous conversions number as part of the configuration of MAT. So I can say, OK, I'd actually like to do 3 at once. Because when you're not using the UI of MVMC, it does allow you a bit more flexibility. So I'll do 3 conversions at once in this case. However, where we really start to scale is when we bring in other machines to use for conversion. So let's say we've got some spare machines, physical or virtual, that we can use and put MVMC on as the engine. So we install it in those 3 places. And we tell this control machine in the variable and config files that those 3 machines exist. So now we've got 4 conversion machines. We've got the controller, and we've got the 3 that we farmed it out to. So you can think, OK, I can take this approach, and I can actually start to scale out my MVMC. Because my list is in the database. Let's say there's 12 on there. Each one of these can do 3 at once. So I can get through that conversion in quicker time. In terms of me as an administrator having to do configuration, it's a lot quicker. The conversion time won't change. It's just now we're operating multiple conversions at the same time across multiple machines. What you've got to bear in mind now, though, is each one of those machines that's doing multiple conversions, it's going to need some horsepower to handle all of that, and capacity on the disk. Okay, so they're things to bear in mind. But that's a simple example of how you can start to use MVMC, and it's free, you can download it, and because it's just PowerShell, you can edit it, you can customize it, you can tweak it, you can really tailor it for your environment and just go to town and really drive it through community to enable more automation. So that would be a completely free solution. But as I said, it would still take time. Now, when we think about migrating to Azure, yes, I mentioned migrating to Azure using MVMC. My preference would be to focus on what I'm going to talk about next, rather than using MVMC for Azure. MVMC is fine, but the technology we've built in Azure Site Recovery is better. Now, when you think about workloads, migrating them to Azure, why would you want to do it? Well, you want to think about how you can start to reduce burden on IT, reduce lower costs for the infrastructure if you're thinking about maybe a second data center or expanding your capacity. Azure may be able to do it at lower cost. You've got control. You can start to integrate with a hybrid experience by extending your network to Azure. And it's very scalable. Hyperscale has been a term that's been thrown around to describe Azure and other similar services in the public cloud. And you can increase your agility on demand. So as you need more, let's just consume more. But you think, well, how do I get my workloads to Azure to do that? And that's where the tools that I'm going to talk about will help. But there are a few things that you need to consider. Well, okay, we've got to reduce the downtime of production workloads during migration. That's important. If I'm going to migrate to the cloud, I don't want my workload to be offline for ages. Think about that MVMC process we talked about before. It's got to do the conversion, downtime. Then it's got to push the disk to Azure, which, depending on your link, might take a while, downtime. And then you've got to create the VM and attach it. There's still a little bit of downtime there, and then get things running. That, for a line of business application, it's not going to wash. That's just not, it's not going to happen. Not for production workloads. So we need to make sure that the solution, whatever we propose, takes that kind of thing into account. You might want to test applications first. I'm just going to move my line of business apps into Azure. Here we go. Go. Done. Oh, no, it doesn't work. OK, we need to make sure that we test first. Now, Microsoft applications, it's well documented what is and isn't supported on Azure. So, for instance, SQL Server, fine. SharePoint, fine. Exchange, up until recently, hasn't been supported. You know, those kind of applications are something you've got to think about. And then finally, I want to make sure that I've got a solution that I can replicate data once and make the decision about whether I want to do a one-way migration or maybe I want to use Azure as my DR and replicate and migrate back at a later point. Having a tool that gives me flexibility to choose is very valuable. And that's, again, where Azure Site Recovery starts to really deliver. Because it's one migration solution, even though the name is Site Recovery, it's one migration solution for a heterogeneous infrastructure. So I can move, migrate, even Hyper-V workloads up to Azure. I can migrate VMware workloads up to Azure. And in the future, or in preview actually, physical and or AWS into Azure as well. And this is using technology that we acquired back in July time, roughly last year, 2014, from InMarge. And InMarge gives us a very much a granular OS-level replication from somewhere to somewhere, in this case, vSphere to Azure, AWS for Azure, and so on. The challenge at the time was, through the acquisition, it was still a very disconnected technology. It wasn't part of the Azure Site Recovery stack. It wasn't part of the configuration, the UI, or anything. Now you can start to preview and utilize the migration tools as part of ASR, but they're all actually part of ASR now. So the InMarge engine is being used to drive some of these heterogeneous replications and recoveries, but we're using the Azure Site Recovery UI. So it's a single scenario that covers all of these different use cases. But from a migration perspective, you're thinking, OK, so Azure Site Recovery, it's not just used for DR, it's for migration as well. OK, great, that makes sense. Do I have to pay Azure Site Recovery licenses or subscription costs for a migration? And the answer is no, and we'll come to that shortly. But in terms of what gets deployed and architecturally what's happening, imagine you've got a scenario where you've got Azure on the right, you've got some stuff that you've deployed in Azure that's going to power this conversion. You'll see there's a couple of virtual machines that get deployed in Azure, IaaS, by the tool. It's not something you have to do drastically manually or anything. But it enables you to say, OK, I need the config server and the master target. These are two key components of the conversion. And those workloads, if we look at customer one, they've been converted from on-premises vSphere and physical servers utilizing what's called the process server that sits on the on-premises location. So you've got a Azure Site Recovery component or appliance that's pushed down. You configure that, you point it at your vCenter, and then you start replicating data. And the way the replication works is it's on all the time, replicating the delta changes, so that when it comes to the point where you do want to hit the button and migrate, it's very fast. One goes down, shut down, final changes, bring the one up in Azure. So you've got a lot more flexibility, and it ticks that box of workloads being offline for a significant period of time. It's not a completely seamless transition. There is some downtime. It's not magic. It's not like a live migration to the cloud across platforms, products, and everything. That would just be science. That would be science fiction. But it's certainly a fast way to migrate workloads without downtime, to the perceived downtime to the workload from a user perspective. Only very minimal, minutes at most. Now, when we think about some of those components, do I have to deploy them all manually myself? No, the Azure Site Recovery UI and the experience walks you through configuring a lot of that. When we think about migration, there was a tool called the Migration Accelerator. You may have heard of it. It was preview in North America only. That was our tool that was very much still in the InMarge UI, the InMarge experience. It was pretty complex to set up. We made it available as a preview over the last couple of months, and it enabled you to replicate and recover into Azure, or replicate and migrate into Azure more specifically, as a free tool. However, that tool is now, all the functionality, all the capability, and more has been superseded by Azure Site Recovery. I mean, why wouldn't you? Azure Site Recovery there's a lot of investment going into it, there's a lot of capability going into it. We want to offer DR for VMware environments as well. So migration is just one half of DR. It's just the replication and recovery one way and not back. So it makes sense to use the same tool. We just have to be clever about how we make it available to people. It incorporates a lot of feedback from that Migration Accelerator around the complexity, the setup, and so on. A lot of that has been taken into account. The product is a lot more simplified now and means you can replicate and recover a lot quicker. So we automate the deployment of those process server, the master target, the configuration server. Automated. Because before, it wasn't. And that's where the complexity came in, as you were reading through the manual, page after page after page. It's very flexible in terms of what you need on premises to be able to pull the data out. The mobility service, which is handling the collection of data. Streamlined installation so we can collect the data, the replication data, more efficiently. And then it's a unified experience, which is the best thing out of the lot. Because it just means that it's streamlined, it's easy to use, and you can manage it side by side with your DR if you're choosing to use that as well. So I could be sat in my ASR portal. I've got DR from Hyper-V to Azure. I've got migration from vSphere to Azure. I've got on-premises Hyper-V to Hyper-V site recovery. All of those scenarios that ASR supports just in a single view. So it's very powerful. When we think about scale, this is running in Azure. It's getting tested and battle tested by a lot of people every day. So again, utilizing it, security, scalability, very beneficial. So if we take a quick look at the demo for this one, let me just come in get out my machine here. Flick over. So you'll see Azure Site Recovery should look pretty familiar. We've got a vault that we've created, and you'll see my options here to set up recovery. I can choose from a number of different options. Some of these have been around for a while. Some of these are more recent. The most recent one is between an on-premises location that's got vSphere or physical and Azure. So I'm replicating from on-prem to Azure. In this case, it's just going to be a single migration, but the setup, the configuration is the same as if I'm doing migration, as if it was DR. If I select that one and scroll down a bit, you can see it's not a drastically long list of things to do to set this up. If anyone's deployed Site Recovery Manager from vSphere, the native VMware tools, SRM, you'll know that it's more than 4 steps. It's a little bit more complex. But with Azure Site Recovery, we're trying to work harder and harder each time we bring new features to the platform to make it easier and more streamlined. So you'll see in this case, prepare the resources in Azure. So those 3 links, deploy configuration, get the registration key sorted, and deploy the master target. It's automated, as I called out in the slide. So there'll be a few items that we need to enter, but the actual deployment of the VMs and the configuration is all automated. And these VMs will be deployed to Azure IaaS. So there will be some Azure IaaS charges that you would pay, but you wouldn't be paying for the conversions per se. The process server gets deployed on-prem. The vCenter you'll already have. Now, this one does require vCenter. So this isn't one that we can target ESXi directly. So vCenter, give it the information, the credentials, bring it in to the environment. And we can then start to create protection groups. Protection groups being groups of virtual machines that we want to replicate and migrate, or in a DR scenario, replicate and failover. And if we look at servers here, you'll see I've already got my Contoso environment here. So Contoso OCS, my configuration server, it's protecting vCenter, or it's connected to vCenter and enabling me to protect the virtual machines that are running on there. And if we look at the protected items, you'll see I've got a SharePoint protection group, which consists, in this case, of 2 virtual machines. And you'll see the RPO, I get information about the recovery point objective, very, very small. So we're maintaining that copy of that data. We're replicating rapidly to ensure that if we do want to fail over or migrate or fail over in a DR scenario, that we're not going to lose data. We're going to migrate very quickly and get the workload up and running very quickly as well. And when we look at the configuration of this particular protection group, you'll see we've got some information about the on-premise source or on-premises source, the target, but these are the important settings here. Remember, this is still in preview, so this may change as we go forward. But you'll see one really important item, aside from the thresholds that you define for recovery point objective, retention, and VSS snapshots, which are all important in themselves, is this multi-VM consistency. Because if you're replicating a set of virtual machines, for instance, a SharePoint site, it's probably a SQL server or 2, it might be an app server or 2 or 3 or more, and web servers. You want to make sure that they are consistently replicated in relation to one another. You know, you could replicate a web server that's out on its own. You could replicate a database server that's an individual on its own, replicate them independently, and everything would be fine. But when stuff has got integration with one another, like SharePoint does across these 3 or more virtual machines, when you replicate them, you want to make sure that they are consistent with one another. And that's where this multi-VM consistency comes in. So by turning that switch on, Azure Site Recovery through the InMarge technologies is really starting to configure that more advanced granular consistency between those VMs. So it ensures that when you do fail over the protection group from on-premises into Azure, it's failing over together, they're starting together, and they're consistent across one another. So you don't get very random experience there. When we think about recovery plans, what's a recovery plan? We're not recovering. We're not recovering from somewhere. We've not had a disaster. No, but that's the term that's given to a disaster recovery plan or a runbook of series of steps. We use the same terminology if it's a migration. It doesn't matter. A migration is just a one-way execution of the recovery plan. And if we have a look in here, you'll see that firstly we'll shut, and this is a planned failover scenario let's talk through. So we've got the migration ready, we've replicated our VMs, our vSphere VMs into Azure, we're ready to hit the big red button. So I click, OK, all groups shut down first, all groups expand the first VM that's going to move, the second VM is going to move, and obviously if it's a more complex environment you would have more VMs in each of these groups for failover. But this is determining which order we bring things up in once we're replicated over. And you'll see I've also injected some scripts to open certain ports, check SharePoint access, and so on. And from there, it's a case of just clicking failover. Where do you want to go from? On-premises vSphere into Azure. Do you want to use the latest point in time or a specific application consistent recovery point, like a VSS snapshot point? You can use that as well. And then click go. And just like that, the process kicks off, and off you go. And that, in a nutshell, whilst that demonstration could be equally used for a disaster recovery versus a migration. With a DR, the same process would be executed, but replication would replicate back, once your VMs are in Azure. So we replicate back down to on-premises. If you're doing a one-way migration, that's not relevant. So some of the actions. You create a recovery vault. You deploy those 4, or you go through those 4 steps to deploy the stuff, the infrastructure components. Some of it lives in Azure, some on-prem. You register your vCenter with the service. So we saw my Contoso OCS already there, my configuration server. We configure protection. What do we want to protect, or in this case, migrate? We specify which VMs we want to replicate specifically. We create the recovery plan that we just went through, and we migrate. And that's as simple as it is. It's not difficult at all. You think, OK, well, what are some of the requirements? Well, for the process server that lives on premises in the data center with the vSphere VMs, it needs to be a decent size. Not massive, as you can see, 2 procs, 4 gig of RAM. That's not big. The more you throw at it, the faster it will be able, and the more it will be able to handle. But you need to have the bandwidth. If you're replicating 1,000 servers and they're changing frequently, you're going to need a decent amount of bandwidth to push up to Azure. That's where things like ExpressRoute might become valuable to you, that dedicated pipe that gives you more bandwidth through to Azure. Don't need any inbound ports. And the stuff that gets deployed in Azure as part of the process, those config server and the master target, you just need a subscription with sufficient resources, at least a standard A3 VM for the config server and an A4 for the master target. So as I said, there are some Azure charges for IaaS that you need to consider, but they're not drastic. And the migration itself would be free. The D14 is a little bit bigger if you're using the source with more than 15 disks. So that's something to consider as well. That needs to be a little bit more powerful. That would be a little bit more expensive. When we think about the solution matrix of, OK, well, I've got this. Can I migrate to that? I'm going to leave this in as a reference. I'm not going to go through each one here. But if you want to migrate from vSphere to Azure, you can do it today in preview. If you want to go from an older version of Hyper-V, like 2008 R2, you can do it to Azure. This is in preview today. If you want to start replicating some of the vCenter and stuff to Hyper-V using this tool in the future, that's something we're exploring. It's not something we're announcing or anything today, but you'll see the roadmap as we go forward. And when we think about pricing, I've said multiple times it's free, but are there any caveats? Are there any considerations? Well, for the first 31 days, we make it free. So if I set this up, I start protecting a machine, I've got 31 days to migrate that one way before I would be charged, before I'd need a license or a subscription for that. That's usually plenty of time. And my recommendation would be, if you don't think you're going to do it in the next 31 days, don't just protect everything. Do it in stages. The key thing, remember, is that there's minimal downtime for the workload, so you're in good shape. Just the replication might take a while, depending on your bandwidth. There's no cost to migrate Azure servers to Azure when migration is completed within the first 31 days. You just pay for those IaaS resources of those servers, the config server, the master target that's running in Azure. After that, we assume, OK, you're not doing migration. You must be doing DR. That's why you're replicating. You've not done it in 31 days. You're going to use DR. So that's when you start to be charged Azure Site Recovery standard DR prices, as if you're just going to continue replicating from on-prem and then fail over at a later point. So I'm going to change direction now and start to focus on some of the other solutions out there that will give you another perspective on just how you can migrate. And I've got this table, this eye chart, if you will. It's a good reference because it does contain some of the key solutions that are out there, from Five9, from Extreme, from NetIQ, all with different scale limits. They all convert from vSphere, or in some cases from physical as well. Variations in terms of Windows and Linux, whether downtime, you'll see to the left-hand side of the table, the downtime row is predominantly minutes or hours. MVMC would fit on the left-hand side of this table as well. And most of them are, or some of them are free. Some of them have costs associated, whether it's purchase, whether it's with a project, whether it's a per migration cost. So key things to be aware of there. But the right-hand side of the table is where I want to focus the rest of the session, and that's where I've got some partners to come and help me talk about their solutions. And when we think about these solutions, you'll see the scale is large. It can handle large conversions of virtual machines, both individually large VMs and large numbers of virtual machines, in a very automated fashion with minimal downtime across both of them. And that's important if you're going to be migrating at scale. So the first person I want to bring up is Tim, from Director of Product Strategy from Vision. So Tim, I'll give you the floor. And yeah, cool. All right, thanks.
Hello. There we go. All right, so I'm Tim O'Plan, the Director of Product Strategy for Vision Solutions. And we're going to talk about our Double Take Move product. So our Double Take Move product will allow you to go from really anything to anything. So whether that be a physical server, going to another physical server, a virtual server, or into the cloud, you can go virtual into all of those. And then you can also do cloud across all of those different platforms. So we do that for both Windows and Linux servers. It's very nice because, as either an IT administrator or as a partner, you're having to convince either your boss or convince your customer that, hey, you want to try out Azure or you want to try out Hyper-V. You can give them the safety net of knowing that, hey, if you try it and you don't like it, you can easily get back too. You can use the same tool to get back. As Matt noted, we are priced per migration. We are able to go, and we're also agent-based as well. So going into how do we do this, so we are an agent that is installed on the source and the target. It's direct communication in between the source and the target, so there's no additional hardware or appliances that are needed. We are a filter driver. So what happens from a replication perspective? We first take an initial mirror copy of the data that's being protected or migrated and send that across to the target. As that's happening, we will see the writes that are coming down through with our filter driver. As that write gets written on the source, that then triggers our process to send that across to the target, and we write it in the same order that it was written in on the source. We also have, of course, are quite geared for replicating across the wide area network. So we have encryption, we have compression, we have the ability to do bandwidth throttling. So a lot of folks, if they don't want to interrupt their production network, they can throttle it during the day and open things up during the night, to handle the replication so that there's no disruption. We also have the ability to have different levels of queuing that are set up, so we can have in-memory and also disk level queuing as well to handle high latency environments. This is nice from an architecture perspective because we can handle, so if you are going from maybe an older version of Hyper-V and looking at migrating up into Azure, we can do Gen 1 to Gen 2 support. We can also handle Gen 2 up into Azure as well with no additional hops. I know that's a question that we get quite a bit. Because of the way that we're architected here, we really don't care about the underlying hardware, storage, hypervisor, or cloud management layer. So it's very nice. It's very portable. Allows you to go across a lot of different environments. Also, just like to call out, we've been doing this for quite a while. We have a lot of our partners that are doing this. This is a great case study with a partner of ours and also, of course, a partner with Microsoft as well. They're a hosting company out of the Netherlands. They have very tight SLAs, and they were looking at moving off of VMware, moving on to the Microsoft platform. So both up into Azure and onto Hyper-V, and they had very tight SLAs. All the different tools that they looked at had a lot of downtime, and they weren't able to keep their SLAs with those tools. So they came in and talked to us, and they ended up using our Double Take Move product. You can see some pretty impressive numbers on there that they saved. They estimated over 2,500 hours of downtime by using our Double Take Move product. When you start factoring in hundreds of dollars per hour, that number gets to be pretty impressive when you look at the potential, at the cost savings that they have there. The slides are available to you guys, so you can click on the link. There's a lot more case studies. Definitely will help you either from a partner perspective, sell them to your customers, or just helping your management understand that this tool is out there and it's being used quite a bit throughout the world. So one thing that we'd like to really highlight here is our migration up into Azure. This is something that we released and announced last week. It's been in the works, and it's been in preview for the last 6 months. It's our Double Take Cloud Migration Center. So what this is, it's underneath the covers. It's our Double Take Move product. So it's our real-time asynchronous byte-level replication. No downtime. Users are online while that migration is happening. What we've created is a process that's a service that's running up in Azure. So it's a Vision Solutions service that's hosted in Azure, and it serves as an orchestration to migrate workloads off of Amazon's EC2 and VMware's vSphere environments. So I actually have a live demo that I'm going to show you here on how this will actually work. Let's see if I get the right. Five. Thanks. All right, so here's the service. So if you hit migrate.visionsolutions.com, you'd be presented with this screen. And one thing I will note is if you go in and create an account now, we're doing a special of the first 200 people that go in and register. You'll get a free Double Take Move license that's populated in your account. So if you want to give this a shot and don't want to spend any money on it, you can log in and create an account. So you'd go in. The very first thing that you would do from this is you would go in and set your environment up. So, obviously mine's already set up. It's double take move, so you'd populate it with your double take move license. So, you can see I've got, I had a 500 total, so I've got 485 left. The next thing you would do is go in and set your environments up. So you would, if you're set up your Amazon environment, so, you set up you provide your credentials in there. There's no connectivity that you have to worry about. We handle all of that from within the service. You obviously need to provide your Azure credentials because that's where we're migrating to. And if you're migrating off of VMware, we do need to have a site-to-site, or actually a VPN set up. We recommend a site-to-site VPN. The other piece is we do need a proxy server that's installed on the VMware environment, and that's just to help us with the discovery because within the VMware environments, typically everybody only has private IP addresses. We need that proxy server to be able to help see those VMs. So once you have all those set up, it's very easy to go in. So I've already done some discovery, but I will show you other pieces. Actually, let me close that out. So you can see all my environments here are just my VMware. So I've already done the discovery across my VMware environment here. What I will do is go ahead and kick off discovery in the Amazon environment. So what this is doing is it's logging into my Amazon account and discovering all the servers that we have managed, that I have managed in my Amazon account. So it doesn't matter what region it's in, it's going to pull all those in. And so let me filter those down. So all of my servers are all TPL with has my initials in there so I can see them. Part of what we do as we're pulling in this inventory and checking to see all the different servers is we're actually also logging into those servers or trying to log in. So if the account credentials match what the server credentials are, we're able to inventory what's on those machines. So as an example, you can look at this. So on this one, you can see it's got the 172 address. It's got the operating system, the number of processors, and the number of disks. So we use this information to provision the server on the target side. So if you also will note, there's some, we do some pre-flight checking too to help make sure when you do a cutover or do a migration that it's actually going to work. So we found that if there's Windows updates missing when you do the cutover on some of these servers with 2012 R2, it's not going to work in Azure. So we tell you that right up front so you don't have to worry about cutting over and not having something work. So I'll walk you through doing a migration really quickly here. We'll select a couple. So we'll select one out of my VMware environment and one out of my Amazon environment. So we'll name it. Select the target environment. The only target environment we have is Azure. We just give you three very basic selection options. The first one is whether you automatically cut over when that initial synchronization is done, or do you keep it running until you cut over manually. My default is to cut over manually because I like to control when I cut over. You do have 60 days from the point that you start your migration to complete it. Our licensing is good for 60 days. If you need longer than that, you can come back and we can call our support group and we can extend that if necessary. The next one is if you want to do testing, you would deselect this one. You can keep the source server running. You can bring that target server up, and you can test to your heart's content, make sure everything's good. That way you can ensure that the cutover is going to work or the migration is going to work. And the last option is just whether or not you compress the data. It's, if you're using a WAN accelerator, you wouldn't want to select this option. But if you're just sending things straight across, you would want to maximize or use our max compression there. So the next step, this shows you and confirms the servers. Note these are single core 4 gig for one of them and a single core 2 gig. We also, if these had multiple volumes, you could deselect one of the volumes if you didn't want to replicate all the data up there. So what we're doing here, I hit next. What this is doing is it's going into Azure and saying, okay, what's the closest VM size to what you have here? So you can see I've got an A2 for that first one and an A1 for the second. We allow you to go in and select and pick whichever one. We've definitely found that the D1s will boot up a lot faster than the A series. So from a performance perspective, that's pretty nice to go ahead and bump those up. You can leave them as the default if you want. Note here, because I did select something out of my VMware environment, we do give you a warning to make sure that when you're doing your cutover, that you are sending it to your a virtual network that has your VPN set up into it. Otherwise, you're not going to be able to connect with that. So my TIM testnet 2 is the one where I have my VPN set up. You can select whatever storage accounts you have set up. You know, I've got default in that. And that's it. I mean, so I'll hit finish here, and it'll actually kick off the migration. So just with those easy steps, you can migrate 1 to hundreds of servers. You can do all the groupings. So you can see here that this one's kicking off. So it's going out and provisioning the servers. Here's one that was done. So you can see all the different things that it's doing underneath the covers. So we actually will go in and allocate the storage, provision all the servers. We're installing and activating DoubleTake for you. We're handling all the configuration. All the while, your users are online, running. They have no idea what's going on behind the scenes. And when you're ready to cut over, hit the button. It'll shut the source side down. It'll bring the target up. And again, it's just a matter of minutes of downtime at that point. Do we have time for questions? Or we'll get those at the end. And just from a management perspective, so you have a very, very nice dashboard to be able to go on here, so you're able to click in and see what's going on. I do have one that's waiting to cut over. I can cut it over in this point from this screen too, just confirming that I am going to shut down the source server and do the cutover. We're not going to wait for any of these. It does take a couple of minutes to bring that machine up, and I don't want to steal all of Barry's time. So we will go back. Yeah, so I did just basically show on the screen all these different steps. So there's basically 17 different things that are happening underneath the covers as we're doing these migrations for you. So it's really nice just from both from a partner perspective and from an enterprise perspective. You don't have to worry about manually doing all those different things, and you can rely on the automation that's in there. And so with that, I think I will turn it over to Barry.
Perfect. Thank you. I have just a few slides I'll go through, but what I actually want to do in the remaining time is actually do a live migration. I have a 1.8 terabyte 4-disk VM, and if all works well, we will migrate it in the last 8 minutes of this presentation to show how fast our technology is. So my name is Barry Shilmover. I'm a Microsoft Reference Architect. Those of you that have seen me speak before, I worked at Microsoft for almost 10 years, mostly on the System Center and Windows Server teams. I'll give you an easy way to remember my name. If you cross the L and make it a T, you'll never forget it. And my initials are BS, so you can imagine I have pretty thick skin. Okay, so real quick, let's go through and look at what the solution does. So this is our environment. We have NAB controllers underneath. We have our network environment, ESX on the left, Hyper-V on the right, and we have a new tool that we released, we announced this week called On-Command Shift. And it's built on technology we've had for a while. I'll talk about that. But you install it on on a hardware, either it's physical or virtual. It's a piece of software. And what it does is it orchestrates the migrations between VMware to Hyper-V. And I say orchestrates because it actually doesn't copy any files. None of the VM files touch the Shift server. It never leaves the controller. We do all of the magic on the controller. Okay, so what is On-Command Shift? It's built on a tool that we've had in the market for over a year called Mat for Shift. We worked with Microsoft on that same Mat tool that Matt told us about. And we modified it to talk to our controller. Okay, so it's bidirectional. It's near zero touch. You'll see in the demo when I kick it off, if the demo gods are nice today, you'll see it live. If not, I'll show you a video. I don't do anything until it's done. I kick it off and it just runs. It's controlled via PowerShell, so it's all scriptable, and it takes literally minutes regardless of size. So how does that work? Well, one of the things that we have the ability to do is we know the file system. We have it's called the waffle file system. We know when you have a VMDK on our storage, we know exactly where the blocks are. We know how they're put together. We know where they sit. So when we clone, it's a flex clone technology is what we call it, we literally clone the file nearly instantaneously. How do we do that? We don't actually write any new blocks. We just have pointers that now point to files to the same block. Think of it this way. When you're an Explorer, if you go Control-C on a large file and Control-V in a different folder, what happens? It takes a while and it copies it, right? If you go Control-X, Control-V, what happens? It instantly switches. Why? NTFS is just remapping the pointer from that folder to that folder. We're doing that on a grander scale. We also have a PowerShell toolkit, and within that toolkit are commandlets to allow us to convert from VMDK to VHD or VHDX. We can do that while cloning. So now for the VHDX, we know that A through D are shared across both files, but that E and F are different. So when I have those two files on the disk, I only have one copy of the disk, and there's a little bit of extra storage used for the metadata. So I'm not doubling the storage. And we just create the VM at the other end. Real quick, here's what we do, and I'll actually walk through this as I do the demo. We snapshot the VM that coalesces it, gives us a nice image to work off of. We clone it. We collect all the disk information. We uninstall the VMware tools, shut down the VM, clone and convert, and then do the reverse on the other side. Create a new Hyper-V VM, mount all the disks, and then rehydrate the network and disk settings. Okay, so let me see if I can get the demo gods to shine down on us today. So real quick, this is my ESX environment. I'm going to convert this tech-ready VM. You can see it's 1.8 terabytes. And here's the VM running. It's right here. Come to the console. So here's my VM. Let's minimize that, and I'll set up the environment. Here on the left, this is my ESX environment. We have the ability to expose the folders through NFS to ESX and through CIFS to Hyper-V on the same volume. So here's my ESX environment. Here are my disks. Here's my Hyper-V environment, my Hyper-V server, and let's actually do this. So I'll just convert virtual machine. I'll give it the name. The source is going to be ESX. The destination is going to be Hyper-V. That's going to put it into the queue and start the job. So let me write this little script and see if the gods are shining down on us. They are. Okay, so it started the process. It's just verifying my environment. Now I want you to watch a couple of things here in a second. Watch these files, and if you blink, you will miss it. What we do, the first thing we do is we clone the original files. This is our get out of jail free card. If anything happens, we can fall back. Watch. Watch as we scroll. They're there. Did you see it? So it's nearly instantaneously on all 4 files. So now I have 2 copies of each of these. Okay? I have 2 500 gig, 2 600, 2 700, and 250. In fact, I don't. I only have 1 of each. But Windows thinks that I have 2 copies of them. Okay? Now I'm pre-staging the environment. This takes about 2 minutes. What we're actually doing is we're collecting all that disk information. We're creating configuration files specific to this VM. We're injecting a bunch of PowerShell. We're modifying the registry temporarily. So when I bring that VM on the other side, what will happen is we'll log in, execute this PowerShell, and rehydrate everything for you. All you have to do as an administrator is go in and make sure that it migrated. Of those 2 minutes, about 1 minute and 45 seconds is uninstalling the VMware tools. That is by far the longest process of anything that we do. Okay, so while it's doing that, let me kind of compare this to, and I'm going to throw Matt under the bus here for a second. Let's compare this to MVMC, okay, to a cold conversion. So it's going to take me about 6.5 minutes from start to finish, from when it's running in ESX to when it's running in Hyper-V. 6.5 minutes. In those 6 minutes, I can leave this room, I can go to Starbucks, assuming there isn't a big line, stand in line, get a coffee, come back, and enjoy a nice cup of coffee. With NVMC, it's about a gig a minute. 1,800 gigs, that's 1,800 minutes, that's 30 hours, that's 1 day, 6 hours. I could leave this room, I could catch a cab to the airport, I could fly to Seattle, I can take a cab over to Pike Place Market, go to the first Starbucks ever, stand in line, get a cup of coffee, tour Pike Place Market, see the flying fish, go up the hill, watch the Avengers, it's going, we're waiting, watch the Avengers, dinner and drinks with friends, go back to the airport, fly back, come back here, and I'll have about 6.5 hours to kill. Let's call it that, okay? It's productivity. And that's assuming that everything works, okay? Now, I said that we've cloned these disks. These are a get out of our jail free card. That's these particular ones. What we're going to do at the end, as I continue to talk while this thing finishes, while it installs the VMware tools, what it will do is the last step that we do is we reverse the process, right? We take these files that you see. Actually, let me come back to that. It started the conversion. Watch how quick it converts those disks. Every 4 seconds or so, it converts it. So now these are VHDXs. I actually only have 1 copy of the file on the disk, but it looks like 3, and there's about a meg per file that's different. It's the only difference between those 2 files is about a meg of metadata. It's created this. Now it's created it. It's assigning it, so the network's not connected yet. It's adding memory here. As I'll switch back, we'll see in a second, it's going to update it. It's going to go from 1 gig to a maximum of 4 gigs. And it's going to start that particular VM. Okay? What it will do is it's actually going to mount to everything, all the VHDs to it. It's going to connect into it. It's going to start that particular VM, and then we'll rehydrate the network. Okay? The last step it will do, like I said, is it will take these back files and replace them and make them the VMDK files. This will set our ESX environment back into the way it was before we started the migration. Okay? This is non-disruptive. So if anything happens to the Hyper-V VM, say there's an app that just doesn't want to work or you have to do something, what we will do is we will actually come back and we will just start the VM and we're back up and running. Okay? I think I'm out of time. But so give it a couple more minutes, and it will actually bring that particular VM up online, and you're good to go. One thing I forgot to mention is the price. If you have a NetApp controller, it's free. It's included in the license of NetApp. So if you have FlexClone, NFS, and CIFS, which most of you will have if you have a NetApp controller, you can just do this for free right now. As we add features and functionalities, we'll look at the licensing, but as it stands today, it's available for you for free.
Cool. Well, I'll just wrap up and summarize while that's going. So thank you very much for staying. So you've seen a number of solutions there, MVMC, Azure Site Recovery for migration. You've seen some cool stuff from Vision. You've seen some cool stuff from NetApp. There's choice out there. There's choice to help you migrate your workloads from one place to another. So if you do have any questions, please come up. I'll hang around for a little bit to answer those. But thank you very much for your time. Enjoy the final day, enjoy the party, and safe journey home. Thank you.